All right, welcome. If you're building a career in IT, networking, or as a Linux pro, understanding the difference between a CPU and a GPU, well, it's not just good to know anymore. It's absolutely crucial. In this explainer, we're going to break down exactly what you need to know, not just for your day-to-day job, but to nail that next interview or certification exam.
So let's start with the big question, right? We're living in an age of AI, machine learning, and just unbelievable amounts of data. The demands on our processors are totally off the charts. So why can't the good old processors that have been the brains of our computers for decades just handle it? The answer to that question is really the key to understanding where computing is headed.
Here's our game plan. We'll kick things off with the why, the whole AI processing problem. Then we'll get to know our two specialist chips. We'll put them head-to-head in a detailed showdown, see how they're actually used out in the wild, and then we'll wrap up with a playbook full of the key talking points you'll need to ace those technical interviews. Okay, first up, the AI processing problem. See, modern stuff like deep learning isn't about one or two really hard calculations. No, it's about doing millions or even billions of very similar calculations, like huge matrix multiplications over and over again on massive data sets. And that, right there, is a massive challenge for the way computers have traditionally been built. And this is really the heart of the matter. The very design that makes the traditional processor amazing at running, say, your operating system or a piece of complex software suddenly becomes its biggest weakness. It just gets bogged down by the sheer volume of simple, repetitive tasks that AI and big data throw at it. It's kind of like asking a brilliant surgeon to dig a ditch. They could do it, but it's not what they're built for. And this is where our two specialists come into the picture. The CPU, the central processing unit, and the GPU, the graphics processing unit. The best way to think about them isn't as rivals, but as two totally different experts on a high-tech team, each with their own unique job to do. First, let's talk about the CPU. This is the brain of the whole operation. It's the master of doing things in order, what we call sequential tasks. It has just a few, but incredibly powerful and smart cores. Imagine a world-class head chef. They can take a super complicated, multi-step recipe and execute it flawlessly, one masterpiece dish at a time. That's your CPU. It's all about speed on a single, complex job. Now, on the other hand, meet the GPU. This is the master of doing a ton of things at once, parallel tasks. Instead of a few smart cores, it has thousands of simpler cores. So back in that kitchen, don't picture one head chef. Picture 1,000 line cooks all standing side by side, and all of them are just chopping carrots. Each one is doing a simple, repetitive task, but together they're getting a mind-boggling amount of work done, all at the same time. That's the GPU. So you see, it all boils down to this fundamental trade-off. The CPU is built for sequence, for complexity, for low latency. That's just a fancy way of saying it does one thing really, really fast. The GPU, though, is built for parallelism, for volume. It's all about high throughput, how many total things it can get done at once. Grasping this one difference is the key to everything else. All right, let's put them in the ring head to head. This table breaks down all the key differences, and trust me, these are the details you're going to want to have in your back pocket for any technical discussion, exam, or especially an interview. As you look through this, you'll see that every single difference here, from the insane core count on a GPU to the type of memory it uses, all comes back to that one core design choice we just talked about. The CPU has a few genius cores and super fast cache memory to nail one complex problem at a time. The GPU, it's all about brute force. Thousands of simpler cores and a massive amount of VRAM to just crush thousands of simple jobs all at once. And what's the result of all those different design choices? Well, look at this. It's staggering. For the kinds of parallel tasks you find in AI, a GPU isn't just a little bit faster. We're talking 10 to 100 times faster. That's not just an upgrade, that's a complete game changer. It's literally what makes modern AI possible. We're talking the difference between an AI model training in a couple of hours versus a couple of months. Okay, the theory is cool and all, but how does this actually play out when you're on the job? Let's get practical and look at what this means for careers in networking and Linux. If you're in networking, you're not choosing between a CPU and a GPU. You're managing how they work together as a team. The CPU is still your trusty workhorse. It's running the network operating system, handling routing, managing firewalls, all the core stuff. But that GPU, that's the specialist you call in for the heavy lifting. Think AI-powered threat detection that analyzes network traffic in real time. Knowing how to deploy and manage both is critical for modern cybersecurity. And for you Linux admins out there, it's a very similar story. Your CPU is running the show, the kernel, all your scripts, the standard processes. The GPU is this incredibly powerful piece of hardware that you'll be responsible for managing for very specific, high-performance tasks. And yet, that means you're going to get your hands dirty with installing the right drivers, working with toolkits like NVIDIA's CUDA, and making sure the correct kernel modules are loaded so applications can actually talk to that powerful GPU. So let's bring this all home. Here is a playbook, a cheat sheet, if you will, that you can use to absolutely crush the technical questions in your next interview or on your next certification exam. Picture it. You're in the interview, and they ask, so can you tell me the difference between a CPU and a GPU? You don't want to just spit back a textbook definition. No, you want to show that you understand what it all means in the real world. So let's get you ready for that exact moment. Have these talking points locked and loaded. You start with the core difference, sequential versus parallel, low latency versus high throughput. Then you immediately give a practical example. The CPU runs the Linux server itself, while the GPU we've installed is busy training a machine learning model. Then connect it to a business need, like AI-driven network security. And for bonus points, if you really want to impress them, mention a specific framework like NVIDIA's CUDA. That shows you're not just repeating things you heard, you know the actual ecosystem. And if you really want to show you've got real-world experience, be ready to talk about troubleshooting. If they ask, just walk them through a logical process, just like this one. You'd say, well, first I'd check the driver status with a command like NVIDIA-SMI. Then you'd move on to physical issues like, is it overheating or does it have enough power? And finally, you'd check the OS itself to make sure the kernel modules are loaded correctly. Walking through steps like this shows you're not just book smart, you are job ready. So here's the big takeaway. The future is not about the GPU replacing the CPU. Not at all. It's about their powerful partnership. A truly modern IT pro needs to understand the unique strengths of both and, more importantly, how to make them work together. This is especially true as AI gets baked into pretty much everything we do. And that leaves us with one last big thought to chew on. As these AI workloads just continue to explode and dominate computing, what does that mean for the future? Will the CPU, which was once the undisputed star of the show, eventually become, well, just a sidekick? A system manager that makes sure the lights stay on while the GPU does all the really heavy lifting? It's a fascinating question, and the answer is going to define the next decade of technology and our careers right along with it.